On September 30th, 1999, a criticality accident occurred at a nuclear fuel facility near the village of Tokai at the Ibaraki Prefecture in Japan. This accident resulted in the deaths of 2 workers from severe radiation poisoning. This incident caused the nearby population to be exposed to radiation and was considered the worst civilian nuclear accident in Japan prior to Fukushima in 2011. Now, you might be able to argue that this was worse than Fukushima since no one died from radiation at Fukushima, but that's the subject of another video. So, what happened at the Tokai accident, and could it have been prevented? First, let's talk about what they were doing at this facility. This facility was a nuclear fuel processing plant. Most nuclear reactors require the use of enriched uranium fuel in order to operate. In the case of this accident, though, they were processing the enriched uranium in order to purify it to be used in fuel. Now, what is enriched uranium? Well, the most common isotope of uranium is uranium-238. In fact, 99.3% of all uranium on the planet is this isotope, but only about 0.7% of naturally occurring uranium is uranium-235, and that's the isotope that we need to operate most reactors in the world. This small amount of U-235 is less than what most reactors need, so it must go through an enrichment process. Modern commercial nuclear reactor fuel is usually in the 3 to 5% enriched range. And in order to understand what a criticality accident is, first you must understand what fission is. So fission occurs when a neutron is absorbed by an atom, in this case uranium-235, and then the atom becomes unstable, and it splits in parts. This results in the release of fission products, a significant amount of energy, and 2 to 3 neutrons per each fission. Now this is important because these neutrons can then go on to cause more fissions. I mentioned this was a criticality accident. Criticality is a state where there is enough excess neutrons to have a sustained chain reaction resulting in continuous fission reactions. In a nuclear reactor, this is a controlled process that results in a safe, stable reaction rate in order to produce a consistent power output. So what happened at this facility that caused a critical reaction to occur in an uncontrolled manner? First, let's talk a little bit about the process that was supposed to be followed. This was a purification process to remove any contaminants. Enriched uranium oxide powder is first dissolved in nitric acid in a dissolving tank which creates uranyl nitrate. This solution was then to be transferred into a buffer tank to ensure proper mixing. This tank geometry was specifically designed such that the criticality was not possible. That was then sent to a precipitation tank and mixed with ammonia, causing a purified uranium compound to precipitate out of solution. So that would collect at the bottom of the tank, and any contaminants would continue to be maintained dissolved in the solution. This entire process was designed to ensure that a critical reaction could not occur. This process, if followed, would prevent the addition of too much uranium to this precipitation tank, which could cause a critical reaction, and in this case it did. So here's what they were actually doing. To expedite this process, the workers bypassed most of this system. They dissolved the uranium oxide with the nitric acid in a steel bucket and then just dumped it straight into the precipitation tank. There was no thought for proper amounts, no understanding of this carefully designed process, just dump it into the tank. This had become standard practice at the facility, and it was actually an approved local procedure. So if they'd been doing it this way previously without incident, why did it cause an accident this time? Well, this time was different. Normally the facility was processing uranium at 5% enrichment, but today they were processing 18.8% enriched uranium that was to be used in an experimental breeder reactor. So that means for the same amount of uranium dissolved, about 3.5 times more uranium-235 was present. So the probability of achieving a critical mass in that precipitation tank was significantly increased. This was the first time in about 3 years that the facility had processed uranium at this high of an enrichment rate, and the process had been changed since the last time they had done it. So this was the first time they had used the new process for this high of an enrichment rate. The established safety limit for the amount of uranium in the precipitation tank when using this type of uranium was about 2.4 kilograms. The way they were doing this process, they were putting about 2.4 kilograms in each bucket that they were dumping into the tank. So when the workers poured the 7th and last bucket in, that was about 16 kilograms of uranium in the tank. The workers saw a blue flash, the facility gamma alarms went off, and the workers evacuated. 3 workers immediately felt symptoms of radiation exposure and were transferred to the hospital. Another 56 people at the plant and many of the general population were exposed to elevated gamma neutron radiation, resulting from this ongoing critical reaction in this tank. The critical reaction actually continued off and on for about 20 hours. Eventually, the reaction was stopped by draining the cooling water that was on the outside of the precipitation tank because it was acting as a reflector and making the neutron population inside the tank even higher. Additionally, they added a boric acid solution to the tank. Boron is a neutron poison and is often used to control nuclear fission reactions. A neutron poison is a material that has a high affinity for absorbing neutrons that can be used to control or shut down nuclear reactions. Now, I mentioned the workers saw a blue flash. This was likely a phenomenon called Cherenkov radiation. This is electromagnetic radiation emitted when a particle, like an electron, passes through water at a speed greater than the speed of light in that medium. Think of it as analogous to a sonic boom, but with light. This is the blue glow that you've probably seen pictures of if you've ever done any research on nuclear reactors. Two of the highest exposed workers immediately experienced pain and nausea and had difficulty breathing. Immediately experiencing these type of symptoms is a sign that you received an extremely high dose. At this point, you're talking about major damage to the digestive tract, bone marrow, and soft tissue in general. One of these workers was a man named Hisashi Ouchi. He received the highest dose, which was estimated to be in the range of 1600 to 2000 rem. Instantly fell ill and was taken to the hospital. He spent approximately 3 months in the hospital undergoing a significant amount of treatments before he finally succumbed to his injuries. Masato Shinohara was transported to the same hospital and held on for approximately 7 months before he died from lung cancer and kidney failure. After reading about what these gentlemen went through and what others who I've studied who have died from radiation poisoning have gone through, it is really a reminder of why we have the rules and processes we have when it comes to working with radioactive materials. While it can be safely handled if you have the proper equipment and processes in place, when it goes wrong, it is a potentially horrible outcome. So what happened here? There was a detailed approved procedure that, if followed, would have been completely safe. However, the company had modified this procedure 3 years prior with no input or agreement from any regulatory authorities. This new process, while faster, completely bypassed a carefully designed and approved process with seemingly no understanding of why the process was originally designed that way in the first place. One of the basic tenets of working in a field like nuclear power is that you don't get to change a process or challenge a requirement that you don't fully understand, and you don't get to just change it without a proper, formal technical evaluation and approval from the regulatory agencies. Yes, I know sometimes it feels like there's too many regulations and they just slow everything down and they seem like a burden, but they exist for a reason and they deserve respect. If you choose to not follow a rule without fully understanding the potential outcome, you do so at your own peril. And when you have your employees do so, you are putting them and the public at risk, often without their knowledge. You are violating the trust that has been placed in you by the public. And when you do the same thing over time, you can get complacent. They've been doing it this way for 3 years. It must be safe, right? I suppose this was safe in practice for the 5% enriched uranium, but that was only by chance. They didn't do the evaluation to validate its safety. So when they used the same unapproved process with a higher enrichment, well, we can see what happened. In the Nuclear Regulatory Commission report on the incident, they agreed with the Japanese government's conclusion that the accident was caused by 3 factors. First, inadequate regulatory oversight. The facility was set up to have a poor safety culture. The initial review of the plant license had concluded that there was no possibility of a criticality event because of the process they had. There was an assumption here that the process would always be followed as designed, and this conclusion relied on the use of administrative controls, which can be easily bypassed by human beings. Also, the regulatory agency didn't conduct any periodic reviews or inspections of this facility. Anyone who has ever experienced a visit by a regulator knows how hard those can be, but these inspections are absolutely necessary in order to avoid any drift in safety or control of what it is you're doing. Even well-intended people can get complacent or misunderstand regulations. It helps keep the safety culture healthy. I can guarantee that if a regulator saw them working the way they were working, they would have stopped them and asked, "What are you doing?" I'm not sure if the company had any internal safety auditors, but they're also supposed to be there to prevent this type of gross deviation from safe operating procedures. Second, lack of an appropriate safety culture. In the case of the procedure they were using when this accident occurred, the new procedure had only been reviewed by the manufacturing and quality assurance divisions, but it was not reviewed by the internal safety management division of the facility. Any deviation of an approved process like this has to go through the same level of review as the original process, and it has to get approved by a regulator. Company spokesman even stated that they didn't submit it to the regulator because they knew they would not approve it. They were changing to be more efficient. Efficiency is great, but you have to be thinking about the potential for disaster. So when they got the order for this special higher enriched uranium, no one working at the plant had any experience doing it before. There was no validation that this new procedure was acceptable for this type of fuel. There was no operator training or qualification checks. You know, all the things an organization is supposed to do when working with a potentially dangerous process. And third, inadequate worker training and qualification. So, because the company believed there was no possible way for a criticality event to occur, there was no specific operator training on how to prevent a criticality accident. So the workers don't seem to have been provided with the proper amount of knowledge in order to understand what it was they were working with. to understand how things could potentially go wrong. In the minds of the workers, there was no difference between the work they're used to doing with the 5% enriched uranium and this almost 19% enriched uranium. Worker knowledge is absolutely key to safe operation in industries like this. This is why we have MSDS sheets. This is why we train workers on the dangers of the job. Even if the company hadn't changed the written procedure, this lack of worker training is a potential recipe for disaster because it can lead to people not following the process to make things easier for them without understanding the risk that they're creating. So this was really a failure at all levels, except that I can't really fault the workers. They were just following the process that the company gave them with the limited knowledge that they had. The company failed to fully understand and respect the technology that they were using. They failed to provide their workforce with adequate training so that they could understand what they were working with. They failed to follow established rules for changing their process, and they purposely bypassed both the internal and external reviews required for changing the process. And the regulators failed to understand that this process wasn't foolproof, that anywhere that safety is dependent on humans following a process, there is a risk of organizational drift over time and the safety culture suffering. They should have been performing periodic safety inspections at the facility. I've spent over 25 years working in the nuclear power industry. We pride ourselves in having knowledgeable, trained workers and operators. We are tested vigorously and often, and we train people to understand and respect nuclear power. We respect and follow our manuals and procedures. We don't just change them because we think it's better or faster without going through a rigorous approval process. And we have a rigorous internal auditing and external regulatory structure in order to keep our safety culture on track. Can it make things seem harder sometimes? Of course it can. But we owe it to our workers and to the public who trust us to operate a potentially dangerous technology in a safe and efficient manner. In my opinion, the only way to do that is to have these layers of safety. This incident is a perfect example of what happens when you don't. Ultimately, this was very preventable if only they had had the right safety culture in place.